Alright, I'm going to do number 46 from section 2.1. So this is number 46 in 2.1 for the 11th edition. So your book writes this linear system in this way, and the idea is I'll kind of write down the rough steps of what we're going to do to do this problem. We want to put this into an augmented matrix. Then we want to use row operations to get our guy into this matrix into triangular form. And then finally, we use the triangular matrix and substitution to get a solution. So there's still kind of one step after you've done a bunch of stuff with your matrix, and that's to use substitution. But the substitution is really easy because you get your matrix into triangular form. So hopefully you'll see that as we work through this example. Okay, let's look back at our system. So this system, to be in an augmented matrix, we really want the stuff with variables on one side of the equation, and then anything that's just a number on the other side of the equation. So we really want to move all of this stuff to the other side of the equations. Let's just do that for this first one, and then I want you to do it for the other equations. So if you do that for the first one, you're moving that negative 11 to the other side. So you had x plus 2y plus 2z minus 11 equals 0. So you're just going to add an 11 to both sides of the equation, and you get x plus 2y plus 2z equals 11. So go ahead and do that for the other equations. When you have, you'll be able to get the system into an augmented matrix. Oops. So an augmented matrix just has the numbers that go along with our variables. So what we do is, for each equation, we make a row in the matrix, and then we just record the numbers there. So this was our first equation, so I'll put this in my first row. And I'm just looking from left to right, what are the numbers that I see? Okay, so I have a 1x, so I'll put a 1 sort of like this x place. I have a 2 for my 2y, so I'll put this 2 in next. A 2z, so I put in a 2, and then after the equal sign, that's what goes into this sort of divided off section. I put in 11. So that's why we moved the 11 over. If you do that rearrangement for the other two equations, what you'll get in the end for your augmented matrix is this first row. Your second row will be 1, -1, -1, and then -4. And the last row is 2, 5, 9, 39. All right, great. So we got our augmented matrix. Just going to move this over a little bit. So now we want to do the second step, that was getting this into triangular form. Remember, the idea here is eliminating variables. We'll get back to that at the end with substitution. But sort of keep that in the back of your mind. That's really what's going on. So what we do is we start from left to right, and we find our diagonal entries. So my leftmost diagonal entry is this guy. Right, if you look at the diagonal here, I'll go ahead and kind of draw it in red. There's your diagonal in this 3x3 square. I've circled the leftmost entry. So I want to get zeros below that. So I can see one way to get a 0 right below it. If I replace row 2 with row 1 minus row 2, that'll do it. So the way your book writes this is they put the thing that's getting replaced first, and then sort of okay, this is what I'm doing to it. Row 2 minus row 1. There are definitely different ways you can do this. This is just how I'm going to start it. All right, so only row 2 is changing here. So my first row stays the same. And so does my last row. All right, let's look at what happens to that second row though. So I do row 2 minus row 1. All right, so 1 minus 1 is 0. That's great. That's exactly what I wanted. All right, so we have to do it to all of the entries, all the way across the whole thing. So I've got negative 1 minus 2 will be negative 3. Negative 1 minus 2 is another negative 3. And this is a negative 4 minus 11 will be negative 15. All right, good. I got a 0 here. Now I want a 0 here. So I've got a 2 here. So this was nice because they had just 1s, so I just knew, okay, I can subtract. But since I've got a 1 and a 2, I'll need to multiply something. But really the only way to get rid of an entry is by adding or subtracting rows. Remember the operations we have here are we can swap rows, we can multiply them by something, as long as it's not 0, and then we can add a multiple of one row to another one. So like here, I added row 2 to negative 1 times row 1. That's, that's sort of the same thing as subtraction. Okay, so here I am in this step. I'll write the next guy over here. All right, so what I'm going to do is I think I'll do 2 times row 1. If I do, say, let's see, what's going to be easiest? I think what I'll do is I'll do row 3, and maybe I'll write it like this, plus negative 2 times row 1. And I'm adding 2 rows, and I've multiplied 1 by a number. That's one of the allowable moves. That's one of my elementary row operations here. Okay, only row 3 changes. So everything else is the same. Let me go ahead and write in those other rows. So first row is the same. Just gonna scoot things up a little bit here. So that's still 1, 2, 2, 11. You should be able to see that in your notes. Here we have 0, negative 3, negative 3, negative 15. And then finally, now I need to do row 3 minus 2, row 1. So I'll go ahead and write the work here. All right, so from your notes, go ahead and look. You had a 2 for the first entry in row 3. So I'll write down 2. Maybe we'll leave myself more room. 2. And then I do need to do negative 2, so plus negative 2 times the first entry for row 1 is a 1. So when you do that, you get 2 minus 2 is 0. Okay, so I've got a 0 there. All right, the next entry, moving down, I've got 5 in row 3 plus negative 2 times, and I've got a 2 if I look at the middle entry of row 1. All right, so that's 5 minus 4 is 1. Okay, so that goes in that middle entry. All right, so now my last guy is a 9. That's in row 3, right? Row 3 plus negative 2 times, and I've got a 2 in the last entry for row 1. So that's 9 minus 4 is 5. Okay, and in the augmented part, I have in 39 plus negative 2 times 11. So that's 39 minus 22 is 17. Okay, so I'll put a 17 there. All right, let's go ahead and give ourselves a new page. So my matrix now, after all of that, same top row. I've got a 0 below the 1 here, and negative 3, negative 3, negative 15. I've got another 0. That's exactly what I wanted. And then I have a 1 here. Oops, sorry. 5, and a 17. Okay, great. So it starts to look a little weird. This is sort of my augmented piece. I don't want you to think there are extra 1s in there or something. Great, so remember the diagonal is this part here. So my next diagonal entry is at this -3. I feel like sometimes it's easier to know what to do when your diagonal entry is a 1. This is just a personal thing. You don't have to do this, but I think I'm going to divide the whole row 2 by a -3 just so I have a 1 in that diagonal entry. So I'm doing row 2 divided by -3, just so that I've got a 1 there. But it's not necessary. It's just something I want to do because I think it makes it a little neater. So I have a 0, -3 over -3 is a 1, same here. And then if you divide -15 by -3, you'll get a 5. So I feel like that's a little easier to look at. 1, 5, 17. Okay, so I'm here and I'm trying to get a 0 below this. So I'm just looking at this one guy. So this isn't too bad, right? To get rid of that 1, all I need to do is, let's see, I can do row 3 minus row 2. So let's write that. Row 3 minus row 2. Perfect. Let's give ourselves a little more space, maybe. Maybe I'll just do this right below this matrix here. So I'm doing row 3 minus row 2. And the new matrix I get. So the only thing that's changing is row 3, right? Because I want to get rid of this 1 here. I've kind of underlined it. So row 1's the same, 1, 2, 2, 11. Row 2 is the same, 0, 1, 1, 5. Alright, now if I do, since I've got it right here, I won't write in all of the math the way that I did in the previous. So I need to do row 3, so that's starting here at this 0. 0 minus 0 is 0 still. 1 minus 1 is 0. That was by design, because I want to get zeros below this 1 here. 5 minus 1 is 4. 17 minus this 5 here is 12. Alright, fantastic. So I'm almost to triangular form. Let's just move this over a little bit and move down. Oops. Oh, jeez. Sorry. Technical problems. Okay, so I really recommend that you write down the steps like this as you work, because then you can check your work in case something goes wrong. So the only thing I need to do to be in triangular form is I have to turn this 4 into a 1. So I'll just divide row 3 by 4. So I have 1 over 3 row, 1 over 4 rather. I'm sure there are lots of you listening thinking, oh no, divide by 4. So I have 1 over 4 times row 3. Okay. I have 1, 2, 2, 11, 0, 1, 1, 5. And then 0, 0. That becomes a 1. 4 divided by 4 is 1, and 12 divided by 4 is 3. Okay, so now I'm really in triangular form, and let me try to show you, here's the triangle. And that's kind of where the name comes from. And right, I have zeros below all of the diagonal entries. Right, this guy, that doesn't really mean anything because there's nothing below it. But below this one, I have a 0. Below this one, I have 2 zeros. Okay, great. So now I want to we'll just go ahead and get a new page here so I have plenty of room to work. So we want to turn this into back into equations and then substitute. So I'm in the substitute part of the solution. So I have 1, 2, 2, 11, 0, 1, 1, 5, 0, 0, 1, 3. So now I read off this information in terms of my equations. And I told you at the beginning, the idea here is that you're eliminating variables. So up at the top, let's actually start at the bottom here. Look, you have a 0 in the x spot, so you have no x's. You have a 0 in the y spot, so you have no y's. You have a 1 in the z spot. So that last row is telling you you have 0x plus 0y plus 1z equals 3. Or, in other words, z equals 3, right? That's the only thing. 0 plus 0 is 0. All you've got is a z equals 3, so you have the answer for z. The second equation tells you that you have what 0x is, so I won't even write that. You've eliminated the x there. You have y plus z equals 5. So now if you substitute this guy in here, you have y plus 3 equals 5, which tells you that y has got to be equal to 2. And finally, the first row, if you scroll up here, that first row is 1, 2, 2, 11. So that means that you've got x plus 2y plus 2z equals 11. So let's go ahead and substitute what we know. We know z and y. So we have x plus 2 times 2 plus 2 times 3, coming from our z guy, equals 11, and you can probably already see how this is going to play out. You have x plus 10 equals 11, or x equals 1. Alright, so your final answer is x equals 1, y equals 2, and z equals 3.